Welcome to the Explainer. Okay, let's start with a big question. What if almost everything we think we know about the universe is just a little bit off? Today, we're diving into a paper by Steven Yee that doesn't just tweak our understanding, it proposes a complete overhaul, suggesting that two of the biggest mysteries in physics might actually be the same thing. So this is basically the official map of our universe as we understand it right now. And the craziest part is that everything we can see and touch, every star, every planet, you, me, everything, is in that tiny little 4% sliver. The other 96%? Well, that's a complete mystery, a cosmic dark side that we've labeled dark matter and dark energy. So that 96%, it really comes down to two massive questions that keep cosmologists up at night. First, what in the world is this dark energy that's making the universe expand faster and faster? And second, what is this invisible dark matter that acts like cosmic glue, holding entire galaxies together so they don't just fly apart? Think about it. The Big Bang model, it's great for explaining that initial boom and then the universe kind of coasting outward. But here's the thing. It just can't explain why about 5 billion years ago, something slammed its foot on the cosmic gas pedal. This sudden acceleration is one of the biggest puzzles in all of science. Okay, so this is where the paper we're looking at today comes in with a really radical idea. It's called the big inflation theory, and it suggests we don't need to look for some mysterious new engine that turned on late in the game. Instead, it asks us to rethink the entire story of the universe, right from the very beginning. So here's the core idea. What if dark energy isn't something new? What if it's just a fundamental property of space itself, like a fifth force of nature? And this is the absolute key. It's not something that just showed up. It has always been there, a constant outward push, baked into the fabric of reality from day one. All right, so let's put these two ideas next to each other, because this is where you can really see the difference. The standard model, on the left, sees this late acceleration as a total surprise, a new mystery we need to solve. But the big inflation theory, it sees the universe as just returning to its natural state. The push was always there, it was just being overpowered by gravity in the early days. So this whole idea sets up this epic cosmic tug-of-war that's been going on for 13.7 billion years. In one corner, you've got gravity, constantly trying to pull everything together into tight little clumps. And in the other corner, you have the endless outward push of space itself, trying to tear it all apart. You know, to really wrap your head around this cosmic battle, the author gives us this brilliant analogy that I think makes it super clear. Just imagine the history of the universe as a car on a long road trip. So picture this journey. The gas pedal, that's the push of space. It's been floored the entire time. Right at the start, gravity, in the super dense early universe, acts like someone slamming on the brakes, slowing things way down. But as the universe expands and stuff gets farther apart, the brakes, gravity's pull over huge distances, start to get weaker. And what happens when the brakes fade, but your foot is still on the gas? The car starts accelerating again. And this table just lays it all out, nice and simple. You've got our two cosmic fighters. Gravity pulls, but it's a local hero. It's really strong when things are close together. The push of space, on the other hand, it pushes everywhere, all the time. It doesn't care about distance. It's the king of the vast, empty spaces between galaxies. They're perfect rivals. Okay, hold on, because this is where the theory goes from interesting to, well, kind of mind-blowing. It doesn't just try to explain dark energy. It suggests that dark matter, that other huge mystery, might not be matter at all. It might just be an illusion. All right, to get this, you got to use your imagination for a second. Picture the whole universe as one gigantic bubble that's constantly inflating. Now, inside that giant bubble, every single galaxy is like its own little smaller bubble. So what's the big deal? Well, think about it. As that main universe bubble expands, it's putting pressure on all the little galaxy bubbles inside it. It's squeezing them from the outside in. And here's the punchline. That external squeeze would look exactly like there's a bunch of extra invisible stuff inside the galaxy, pulling everything together with gravity. It would explain why stars on the edge of galaxies are moving so fast without flying off into space, which is the whole reason we came up with the idea of dark matter in the first place. And the author just sums it up perfectly with this quote. The problem isn't that we're missing matter. The problem is that our models are missing the effect that space itself is having on everything in it. We've been looking for a missing thing when maybe we should have been looking at the pressure of the space all around us. So, What does all this mean? If we follow this idea all the way, what does our universe actually look like? Well, the picture gets way, way simpler, and honestly a lot more elegant. It leads to this, a radically simplified cosmos. If dark matter is really just an effective dark energy, then our two biggest cosmic mysteries, they just merge into one. The universe isn't some complicated recipe with three different ingredients anymore. It's just two. 96% is the fundamental push of space, and the other 4% is us, the normal stuff. And this leads to another really wild idea. We're all used to thinking about gravity creating these wells in spacetime, right? Like a bowling ball on a trampoline. Well, this theory says that in the huge empty voids between galaxies, dark energy does the exact opposite. It pushes up on spacetime, creating these vast, gentle gravity mounds. So the universe isn't just a flat sheet with some dips. It's this incredible landscape of deep wells and massive hills. But here's the best part. This isn't just some cool thought experiment. You might actually be able to test it. Remember the Pioneer anomaly? This old mystery where the Pioneer spacecraft slowed down a tiny bit more than they were supposed to as they left our solar system? Well, this theory has a beautiful explanation. Maybe they weren't just fighting the sun's gravity. Maybe they were also traveling ever so slightly uphill, climbing one of these giant gravity mounds created by the push of space itself. And that leaves us with a final, pretty provocative thought. What if the biggest secrets of the universe aren't hidden away in some exotic particle, but are right there, in the nature of empty space itself?